Okay, this is a walkthrough of my midterm from October 11th, 2018. So this first question has a bunch of problems about subset and then a bunch of other problems about elements. So let's start with the subset ones. So it's asking whether various things are subsets of other things. And if we look to start out with, to have a subset, you have to have a set, right? Oops, sorry about that. So, for example, right here, that's not a set, right? So I know that is not a subset. Similarly, not a set, so couldn't possibly be a subset, not a set. Nope, everything else is sets, so it might be a subset. So let's see, this one here is the set containing just an A. So the question is there an A by itself in there? And there is not, so that's not. Next up, here we have a set that just has a C by itself, and we want to see for subset, is everything in here also in here? And we say, well, look at that, it's just a C by itself, and there's a C here by itself, so yes, it's a subset. In this set, we have one thing, one string, and the string that we have is DE. Oops, DE. And I want to know, is DE, right, is the element DE in this big set? And the answer is no. There's two things in this big set. One of the things is the string AB, and the other thing is a set that contains other stuff. And yeah, DE's in there, but it's not DE just as an element. So now here I say, all right, look, is the set that contains DE in here somewhere? And I say, well, what is, and this is the whole thing, right? So is there a set that just contains DE in here? And so on the right-hand side, say, well, that's not a set that is not the set containing DE and just DE. Similarly, this is not the set containing DE and just DE. And there's nothing else here, so no. In order for this guy to be in a set, well, so let's see. So let me give you an example. That, if we move over, right? This is the set containing DE, right? So I can say this thing is a subset of this set, right? And the set DE comma F is also a subset of this thing, because DE is in here and F is in here, right? But the set DE comma G is not going to be a subset of that set, right? And the set, let's say the set containing DE and E is a subset of, let's see, the set containing DE along with F along with E. Can I move up a little bit more? Yeah, there we go. Here, let me, now that I've moved over, I got my pen back, good. E, and I don't know, AB comma C, right? Can I move over a teeny bit more? Yes, I can, amazing. Oops, now I'm moving still, sorry. Here we go. Right? There we go. You can't see everything, shrink it, come on. There we go. Right? But if I have, let's see, here's one last example. Here's a set that has 3 elements. The first element is that. The second element is that. And the third element is that, right? So this is one thing inside of my bigger set, right? And this is the second thing in my bigger set and the third thing in my bigger set. And so, you know, I don't know, the set containing F is not in here, right? Because that says, is there an F by itself as one thing in my bigger set? And the answer is no. And neither is this double sort of set containing F, because this says, is this thing, the set containing F, found in here somewhere, found in this other one? And is this element, the set containing F, does that equal this? Nope, this is different. Does that equal this? Nope. Does that equal this? Nope. All right, so let's go back to the exam. You could also watch my video on sets again if you're still a bit confused. So doing subsets, let's see. So this next one here, let's switch to blue for a little bit. It'll be fun, right? It says, can you find just lambda inside of this set? And sure you can, it's right there. And what about here? Can you find the element lambda by itself in this other set? And the answer is no. I can find a set containing lambda, but I can't find lambda itself. All right. Now, the questions at the bottom here were about element, right? Is an element of. Can you find this thing in the set? So, let's get a pen. Let's go green just because I want to show off all the different colors I have here. So let's see. Is this thing, an A by itself, found in this set? Well, no. Is the set A found in this thing? No, I don't see that either. Is a C by itself in here? You bet, it's right there, so that's a yes. Is there a set that contains C in here? No, there's not. The only way there would be is if we had little set squiggles around that C, right, which we do not have. So the answer to this one is no. Is DE an element of this set? Well, what are the elements of the set? There are two elements. One is this AB, and the other is a set that contains more stuff. So DE is not an element. Is the set containing DE in this set? Well, no, I have an AB, and I have a set containing C and DE, but not just a set containing DE by itself, so no. And then this is, you know, is there a set that only contains one element, and that one element is the set containing DE in this set? No. Now, because we're looking at element, not subset, I'm saying, can you find a lambda in braces in this set? No. But can you find a lambda in braces in this set? You bet. Okay, so this problem is all about union, right? Questions about union. And so it's asking, list all the items that are elements of the set that's the union of these two sets. So let's just write out what is that, and then we can look on our list and figure out what it is. So what is in here? Well, union just means everything you got, right? So we've got, I'm going to take them in alphabetical order just for fun. We have an A, we have a B, we have a C. It appears twice in our list, but when you union it, we're just going to write it once to show that we know that elements only appear once in a set. And we've got D and E. And so now we look, oops, sorry. There we go. Now we look at the list over here and we say, what are the things that are elements, right? It says very clearly here, list the things that are elements of this set. So we got the A, the B, the C, the D, and the E along here, right? And so our answer, I'm going to make this a little bit bigger so I can write, is going to be 8 is A, 9 is B, 10 is C, 11 is D, and 12 is, oops, 12 is E. Should be a 12, right? And there's a 10. Okay. And the next question is asking, list all the elements, list all the items that are elements of this set. So again, let's kind of just go through it and figure out what's in this set, and then we will, and then we can look on the list on the right and figure out what all those things are. Okay, so all the elements of this set, let's just kind of make a list and then we'll write it. So I've got an A by itself, and that's also here. I'm looking at the B's, and I have a B by itself, but I also have the set containing B. So there's a B, that's this guy, and there is the set containing B. I have a C by itself, and then I have the set containing both C and D, right? So now we got to finish this guy. Sorry. So now we look at our list and we say I have an A by itself, so that's item 8. B by itself is item 9. C by itself is item, oops, wait a minute, I didn't do the, well, let's do C by itself is item 10. B in brackets, there you go, is item 4. And C and D together in brackets is this guy is item 20. Okay, so let's do the next one. Oops, I may have to delete that bit. Actually, no, we know it's list all the items that are elements of this set. So we've got two things unioned with each other. So let's just again, let's write down, oops, let me get a pen. Let's write down what the set is that these two things unioned equals, and then we will look up the items on the sheet. So I'm going to do this a little bit. Let's see. So in here there's a D and there's a D there, so I'll write a D. The next thing here I have, okay, so look here. That guy and that guy are the same thing, right? They're just two different ways to write the empty set. So I'll put the empty set in here. And the last thing in this set is a set that has just the element E. All right. So this union that we had before equals this whole thing. And now let's just look those up in the chart. Let me shrink so we can find the chart. And the letter D by itself is item. Whoops, let's see if we can do this. Letter D by itself is item 6, and the empty set is up higher, I think. Yep, there you go. The empty set is item 1. Can you see that? So we have a 1, and sorry, I can't see what's on the screen here. We have an E, the set containing just E. So that's item 7, right? Okay. And let's do the next one. Well, we're listing all the items that are elements of the set, and we look at this and we say, that's interesting. I'm taking the union of a set with the empty set, and of course the empty set doesn't have anything in it, so that means that all that's in there is the stuff that's in my set. So this isn't bad. I just have an A, a B, and a set containing the empty set. So A is 8, and B is 9, and the set containing the empty set, I think I need to look up higher in my list, there you go, is number 2. Right, do you see that right here? Right, it's not just the empty set, it's the set containing the empty set. So what did I say? It was 2. Okay, this next problem is now asking about questions that use intersection, right? An intersection is, it has to be in both sets, right? So if I take, for example, the intersection of A comma B with C comma D, the answer of what is the intersection of A comma B intersected with C comma D is the empty set. But if you say to me, what are the items that are elements of this? Well, there's nothing that's an element of this. It's the empty set, right? So I have to pick none of the above, which is number 22. Notice this is very different from saying the empty set is an element of this, right? It says, what are the elements of this, right? And if you look at my example, say, what are the elements of the set ABC? Well, the elements of the set ABC are 8, 9, and 10, right? Because that's just an A, a B, and a C by itself. And for sure, the empty set, a lot of people here would say things like item 1. Item 1, the empty set, is not an element of the empty set. It is the empty set. So when you ask me what's an element of the set, it's actually number 22. Just none of the above. There's nothing in there. All right, list all the items that are elements of this set. Okay, and again, I have an intersection, which means I need to see what do we have in common. So I'm looking, and this is the set containing A, and that's just a plain old A, so that doesn't give us anything. Ah, look, here I have a B, and here I have a B. So if I'm taking the intersection of these two, I have a B in there. What else? So we dealt with that. Ah, look, I also have a C, right? I got a C in there. And I'm starting to close it before I finish it because I looked at this and I said, well, that is not the same as that, right? So it's not in both sets, so when I take the intersection of it, it goes away. So it is just the set containing B and C. So when I try to answer this question, I need to say, what are the elements of this set? Well, the elements of this set are just a B and a C. So we have item 9 and we have item 10, and that's it. Okay, so let's look at the next one. List all the items that are elements of this set. Now look, I'm intersecting with the empty set, right? There's nothing in the empty set, so anything intersected with the empty set is the empty set, right? Which means there's nothing in here, right? So that's got to be that none of the above answer again, right? So that's going to be item 22, and that's it. And the same thing happens in this next one. It's just that I wrote the empty set a different way, right? So any set that's intersected with the empty set contains nothing, right? That the intersection of these two sets equals the empty set. So what's in there? Nothing, none of the above. Okay, for this set of problems, I ask you a bunch of questions about, could this be an alphabet? Could this be a string? Could this be a language, right? Now, we know that an alphabet is a set and a language is a set, right? And since there's no set symbols around here, and even I say notice absence of curly braces, could A be an alphabet? Nope. Could A be a language? Nope, it's not a set. And same thing down in this second problem here, right? There's no curly braces here. Could it be an alphabet? No. Could it be a language? No, because an alphabet, right, is a finite set of symbols, and a language is a set of strings, and neither of those are sets, so we know for sure no. Could A be a string? Well, sure, look, right? It's a bunch of symbols concatenated together, so yes, it's a string. This guy, however, cannot be a string because we agreed in class that commas are going to be special symbols that separate things in sets, and we're never going to use a comma as a symbol in our language. So could B be a string? No, it couldn't. All right, let's keep going. Now we've got two things that are sets, so they could conceivably be alphabets, right? This first one, sure, it's an alphabet, right? It's a finite set of symbols. It's a set, it's finite, and it's just got a bunch of symbols. So, yep, that could be an alphabet. Could it be a language? Well, a language is a set of strings. These are very short strings, right? This is a string that just has an R in it, a string that just has an O in it. But it's still a set of strings, so sure, it could be an alphabet. I mean, a language. Could it be a string? No way, right? It's not a string because it's got the set symbols. No way. And same here, set symbols, not a string, right? Let's take a look at D. Could D be an alphabet? Well, no, because, right, an alphabet is a finite set of symbols, and we've agreed that individual letters of the English alphabet are symbols by themselves, so this is a bunch of symbols concatenated together, so D is not an alphabet. But could it be a language? Sure, it's a set of strings. Absolutely. Okay, in this set of problems, I give you a regular expression and you have to turn it into a language, right? A set of strings. So let's take a look. Right here I have this regular expression a dot b dot b dot a, right? Another way to write that as a regular expression is just a b b a, and so that represents just a single string in a set, right? That represents the set, right? That represents the language. Come on, the language of that regular expression is just this thing right here, right? And so now we have to look for that in my list, and I think there's one that just looks like that. Yeah, there we go. So item 6. So we're just going to write a 6 in there, and we're done. For the next one, it's a little bit trickier, right? So over here I have a star, b star, right? So 0 or more a's followed by 0 or more b's, all concatenated together. For sure the a's have to come before the b's, right? And one of the things that I said over here in my list of languages is that some of them are a little bit tricky. So we need to kind of look, we need to find something where the a's all come before the b's, and there's 0 or more a's followed by 0 or more b's, but they have to have potentially different number of a's and different number of b's, right? Because like in this language, a star, b star, one of the things in this language is like 1 a and 2 b's, and another thing in this language is 5 a's just by itself, right? There's a ton of, it's an infinite language, right? I'm not going to write out the whole language for you, but these are 2 examples of things that are in the language. So I can't just find something finite. I don't know what I was going to say, can't just. Anyway, I'm looking for a star, b star, and oh, I know what I was going to say, can't just be. Item 7 here is a to the n, b to the n, right? And because they both have that same exponent, that means exactly the same number of a's as b's. And in fact, we've talked about it a few times in class. That's not a regular language even, so there's not going to be any regular expression for it. On the other hand, if we look at item 8, that looks pretty good. A bunch of a's followed by a bunch of b's, and how many a's? Well, n a's where n is in the natural numbers, m a's where m is in the natural numbers. So yeah, that looks good. We'll give that one an 8. If we look at this next thing, a plus b star, right? That is the language that contains, well, lambda's in there, right? And it also has as many a's and b's as you want in any order you want, right? So it's like a, if we're trying to write out languages, lambda, comma a, comma b, and then you've got things that are of length 2. We've got like a, comma a, b, comma b, a, comma b, b, and so on, right? They can have the b's before the a's, the b's after the a's, and so on. And I believe if we look at the list, let's see, it's not going to be item 18 here, right? Because item 18 doesn't have lambda in it, but this one is looking promising. Let's just look. So we have lambda, we have a, we have b, we have, what do we have of length 2? We have a, b, 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 a of length 3. We have yeah, it looks like 1, 2, 3, 4, 5, 6, 7. Yep, there's all the different possibilities of combinations of a's and b's of length 3, and we do have the ... there, so this looks good. So item 19. So that was this one, right? Okay. This next one, a star, b star. So this is similar to the first one, right? The first one was a star, b star. This is the same thing, except you have to have an a at the beginning, right? So in a star, b star, lambda was part of that. Lambda is an element of that language, right? But the language that, the language of this regular expression doesn't have every single element of this regular expression. Sorry, every single element of the language represented by this regular expression has to start with an A, right? So for example, we know that if we just kind of start looking through these, we know item 19 isn't it because lambda's not in it. We know 18 isn't because B doesn't start with an A. If I just start looking at these, 17 has, starting with A's, 17 says you could start with A's and B's, but also union B's and A's, so that's no good. And also that one starts with B's. Here we go, look at this. This is starts with A's and then some B's, and the numbers aren't the same, right? So N and M here, not two N's. And N is greater than 0. That means there has to be at least one A. Oh, but this one says M is greater than 0 also, so there has to also be at least one B, whereas this one, item 14, is looking like the one. A to the N, B to the M, so N and M are element of N, and N is greater than 0. So you have to have at least one A and then 0 or more B's. So that's our guy. So what do we got here? That was number 14. Okay. And now we look at the very last one here. And what does this say? This says, the regular expression says, start with an A and then as many A's and B's as you want, or start with a B and then as many A's and B's as you want, right? So that's probably going to be one of those guys that we had this union thing at the bottom, right? I'm just looking at the other ones, but let's just look at these ones a little bit more closely and see what they say. Oh no, that one doesn't look right? Because these are still, there doesn't say that it has to have at least one, right? We have to either start with an A or start with a B. Lambda's not in this one, and not that one, and it can't be this one because the A's and B's have to be in a special order, right? For item 15, the A's have to come before the B's, so we got to look somewhere else. Hang on. Okay, so let's keep looking. We have to start with an A and then have a B. So, but we could also start with a B. So I'm gonna keep kind of looking, and here wait, look at this. What about item 18, right? Lambda's not in there, and we're looking for something that's essentially A plus B star, right? But it has to start with an A or a B, and I think that's what's going on here, right? So it's any combination in any order, but we just got rid of lambda, right? This is exactly the same set as item 19 that we picked before, but actually it has to start with an A or a B, so that looks good. So that's item 18. All right, for this problem, we're going in the other direction. So I'm giving you a language, right? I'm giving you a set of strings, and you need to tell me what's in it. Or give me a regular expression that represents it, right? So if we look at this first one here, most of you, it's pretty easy to say, oh, well, look, that's almost A star, but you have to have an A, so people will say, oh, that's A star, or maybe you could also write A star A. But of course, in this problem, I said, be careful. Sometimes the answer is not totally simplified, so you might have to think about it for a little bit. So we're looking for something that is the same as A star A. And it's definitely not item 1 because that is just A. And take a look at item 2 for a minute. What have I got? I've got A star, A star, right? So what does that say? It says 0 or more A's followed by 1 A followed by 0 or more A's, right? And that is actually an unsimplified version of A star, right? So that's going to be our answer for this one, right? Because it's forcing us to have 1 A, and then we can have 0 or more if we want. All right. Let's look at the next one. What do we got? At first, it kind of looks like we're having as many A's and B's as you want, except when I look, I have 1B, 2B's, 1B, 2B's, 1B, 2B's, right? 1B, 2B's, all right? And the A's are increasing. So it looks to me like I have to have an A, right? So it's going to be something like A star, and then I can have 1B or 2B's. So let's see if we can find something that looks like that. And, oh, look, I have exactly that down here, right? Item 19, A star, 1B plus 2B's. So that is 19. So we're going to put a 19 in there. All right, next one. Lambda A to triple A, quadruple A. Well, that's obviously A star, right? And the question is, which of these things on the right, that's pretty ugly, isn't it? A star. And the question is, which of these things on the right is actually A star, right? So we got to kind of look through them. If we just start at the bottom, if you look, all these guys have B's in them, right? So they're probably not right. Oh, and notice this, item 12 is crossed out only because in the exam, item 11 and 12 were the same. So if you picked item 12 for something where item 11 was the answer, you should have gotten it right anyway. I'm not sure that that was the answer for anything. We'll know in a minute, but let's see. So we are looking for A star, right? Just a plain old A star. And here's the ones that just have A's. And item 5 is definitely not A star, right? Because that's just got 1, 2, 3, 4 strings in it. Item 4, if you look at it, is forcing us to have at least 2 A's, so that's not A star. And item 1 isn't right? That's just the letter A. But look at item 3 for a minute. It says A star plus A, so that says the set containing 0 more A's, right? A star unioned with an A by itself, which is already a part of that. So that's what we're going to pick. We're going to pick item 3. All right, let's see. Now we have AB to the 2n, right? So what is this set? This is going to be an A followed by, oh, and it says n element of n. So it could be an A by itself, right? Or it could be an A with 2 B's. Or it could be an A, do I have room to keep writing this? Yes. Or it could be an A with 1, 2, 3, 4 B's. Or an A with 1, 2, 3, 4, 5, 6 B's, and so on, right? And if we look around here, and we see what we have, right, we do have to start with an A, right? So we have to start with an A. There's always 1 A and then 2 B's. So I want to look for something that starts with an A and then always has 2 B's, that line. All right, so it's got to have B's in it. So if we just start looking, let's see, it's not item 6 because that could have 0 or 1 B, or, well, 0 B's is fine, but it could also have an odd number of B's. It's not item 7 here, right, because item 7 is saying that you have at least 1 B as well as your at least 1 A, right? Item 8 says you have at least 2 B's, but then you could have an odd number after that. So we need something, this is getting more promising, right? This is closer, right? This says you have to have 1 A and 1 B and then as many pairs of B's after that as you want. But that gives us an odd number of things. But if we keep going, that one looks good, right? A followed by as many pairs of B's as you want. So that's item 13. So let's put A13 in here. And last one, AB to the 2n. Right, so this is saying I could have, where n is an element of n, so this is actually, if I think about what this set is just in set notation, right, that is, let's see, you could have 0 ABs, or you could have pairs of them, right, AB, or you could have, so let's see, so I could have 2 of them, or I could have 4 of them, so I could have AB, 1, 2, 3, 4, and so on, right? And if we look at our options, it's got to have a B in it. It's got to be sort of an eve. Look at this. Item 14 is AB starred, right? So that automatically gives us 0 or pairs of the AB. So it's item 14. And I don't know if you can hear this. I'm recording this in my office so that you guys get this as soon as possible. But the end result is they've decided to do some lawn mowing outside. My neighbors in the offices nearby are talking a lot. Students are yelling lots. Sorry for the background noise, but hope you find this helpful anyway. Okay, in this problem, you are starting with a written description of regular languages, and you need to give a regular expression for it. So this first one says set of all strings over the alphabet A, B, C, D that start with an A or start with a BC, right? So it can be anything in there as long as it starts with an A or it starts with a BC. So you could write something like this. Let's see, you could write A or a BC followed by A plus B plus C plus D star, right? It doesn't say that you can't have any inside of it, right, once you've started it. And it would also be perfectly reasonable to write, let's see if I can find some more space. You could also write, you start with an A followed by, oops, B plus C plus D. I forgot to put the A in, but it doesn't matter where I put it. Plus A starred plus, what was the other thing we had to start with? We either had to start with an A or a BC, or BC followed by A plus B plus C plus D star. So that's fine. That's a reasonable answer. So is this first one that I had there. All right, let's look at the next one. The set of all strings over the alphabet ABC that contain 2 or more instances of the letter B, right? So we have to have at least 2 B's in the language. And of course, in each of these examples, I give examples of what's in there and what's not, and you can look at those and think about it. But we have to have at least 2 B's, right? So if I'm thinking about this just over here, let's use this for scratch paper. We have to have at least 2 B's somewhere, right? It could start with 2 B's, it could end with 2 B's, it could have 2 B's in the middle. And before, in between those B's and after, you optionally have a bunch of A's, B's, and C's, right? Because it says 2 or more instances. It doesn't say exactly 2, just 2 or more. So for this one, what I'm going to say is, and let's make the box a little bit bigger so I have a little bit more room to write. Well, you can start out with anything you want, and then you have to have at least 1 B somewhere in there. And like I said, you have to have at least 2 B's in there. Oops, that anything you want should have a star around it, right? And then you can have the B, and then there can be anything that you want in between the 2 B's that are sort of mandatory, including more B's, right? So I'm saying there's definitely 2, but there may be a pile more. And then after that one, again, can you see all that? A plus B plus C star, right? And it was just over the alphabet A, B, C. Can we just look? Yep, it is. So we're good. Okay. Now this last one, the set of all strings over the alphabet A, B, C that start with a CC and also contain the substring CB. And you see that partway through the exam, I found a couple of examples in there that were wrong, so we crossed them out in class. And I also got to the online exam before, I'm pretty sure before anybody got there. If this really walloped somebody, you can tell me, but I did fix it in the online exam almost immediately also, so I'm hoping that didn't catch anybody. So let's see, what I kind of expected people to do with this is to do it sort of the way we did the previous one, which is it starts with a CC, right? And then after that, it could have anything. So A plus B plus C, quantity starred. And then somewhere it's got a CB. And then after that CB, it could still have, let's see, can I shrink this? There we go, good. It could still have more, right? A plus B plus C, quantity starred. Now the catch is that if you look at what I asked for, there's one string that I give you as an example that still meets the definition that I gave you up at the top, but is in this list and is not in the language that we've defined here so far. And that is this string, the CCB, right? Because CCB, this language that we've defined here will give you a kind of a triple CB, right? So we could get like 2 C's from here, and then another C and a B, right? But it always requires that we have 3 C's. And this piece of the language, it's fair game to have it in the language. So it's not too hard to fix this. But on the other hand, I wasn't actually intending to make it quite so difficult since I didn't point that out. So what I'm going to do is, if you gave this answer, then I am going to give you, then I'm going to take off just like a quarter point or something to make you look and try and see what's wrong with it. But we can talk about what the actual answer should be. And if you get the full answer, then I'm going to give you some bonus points or something. But the actual answer is anything here, but it also could start with a CCB, right? So we could say plus, let me just shrink this more. So plus anything that starts with a CCB, right? So we could just say CCB, CCB, followed by A plus B plus C star. So that whole thing is actually the correct answer, but if you got this first, if you got this first part right, then you'll get most of the credit. Okay, so here we have a very nice, if I do say so myself, DFA or NFA created in JFlap. And I ask you questions like what should be written for the states part of the 5-tuple. So the states part of the 5-tuple should have, let's see, what are the states? We've got a 1, we've got a 2, we've got a 3, we have something called 14 for no apparent reason, and we have Q5, and we have Q6. And of course we need curly braces around that because it's a set. And then the next question is what should be written for the alphabet part of the 5-tuple. So again, it's going to be a set, and we just need to kind of look and say what letters are in here. So I see an A, I see a B, are there? Yeah, there's a C, there's a D. I don't see any E's or F's or G's, but there's a bunch of H's for no apparent reason. Okay, and that's also a set. It says what should be written for the start part, and because we use JFlap, we know that this triangle thing represents the start state. So the start state is just the number 2, right? And then what should be written for the final part of the 5-tuple? The final part is a set of states, and we say what states are accept states, what states are final states, and we have 2, 3, and Q6. And the chart on the right shows part of the transition table for this NFA. You see rows labeled 1, 2, and 3. What other rows are missing? So we look and we know that for this NFA, we need a row for every other state, rows, wait, these are the rows, right? Yes, so we need a row for every other state, and we have, what are our other states? We need a row for, so the rows that are missing are 14, and I'm just looking at my answer up there, Q5 and Q6, right? So that should really go in here, 14, comma, Q5, comma, Q6, right? And on the transition table, you see columns labeled A, B, and C. What other columns are missing? So we need a column for every letter of the alphabet, plus we also need a column for lambda, right? So we have A, B, C already. We need D, we need H, and we need lambda. So the columns that are missing are D, H, and lambda. And finally, it says fill in the boxes in the table for 1A, 1B, 2A, and 2B. So 1 on A, well, it's an NFA, right? So for sure, we're going to have curly braces around everything because it's an NFA. But let's see. So 1 on A, well, 1 on A, it looks like just goes to 1, right? And 1 on B doesn't go to anything. So 1 on A goes to 1. So we have to write 1 on A goes to the set containing 1, and 1 on B goes to nothing, so we're just going to write the empty set. And then we've got to fill it in for 2 on A and 2 on B. So 2 on A, I don't see any. It looks like it's the empty set again. But 2 on B, look at this. 2 on B goes to Q6, and it also goes to 14. So we need to write that down. So 2 on A is the empty set, but 2 on B is Q6 and 14. Okay, a bunch of questions about some automata asking whether they are NFAs and DFAs. So let's look. Can I do that? There we go. Look, let's look at this guy. So it's asking, is figure 8-1 a DFA over the alphabet? So we got to check, does it have a start? It has a start. Does it have an A and a B out for out transition for each state? So for state 1, it has an A and a B out. For state 2, it has an A and a B, and for state 3, it has an A or a B. It looks good to me. Yeah, I know that state 1 is floating out in Never Never Land, but there's nothing about the definition of a DFA that says that you can't have a state floating out in Never Never Land. So yes, and I just get to skip this part. And it is a DFA, so is it an NFA? Absolutely. If it's a DFA, it's an NFA. I don't need to do anything there. All right, let's look at the next one. Sorry, I couldn't understand why that had the number 3 there, but that's okay. It makes sense to me now. So is this a DFA? So let's take a look. There's no except states, which make it, no final states, which make it a little bit scary to some people, but that doesn't mean that it's not a DFA in and of itself. It has an out on A and an out on B and an out on A and B for 2. Yeah, I think that's a DFA. And is it an NFA? You bet. All right. Okay. Here's another 2 very similar problems. Is this a DFA over the alphabet A, B? So we got to see whether everybody has an A and a B out. 1 has an A and a B out. 2 has a B and an A out. 3 has an A and a B out. Uh-oh, look at that. 1 has actually got 2 A out transitions, right? So there's this guy and this guy, and you can't have 2, so no. And I can say 2 A transitions from state 1, right? And now you can see what I have to deal with when I'm dealing with grading. Now it says give one and only one reason, so please, folks, I hope you gave one reason. Actually, here, I'm trying to see if there's any other reason. There's an A and a B, there's a B from everybody, so that might be the only reason in there. But is it an NFA? You bet, right? Who cares if there's more than one transition from a given state? Okay, last one. It's a bit messy, but let's see. Is it a DFA over the alphabet A, B? Well, let's see. There's lambda transitions, so no. So I can immediately write no, there are lambda transitions, right? I could look and I could see if there's like 2 A outs somewhere or not an A and a B or something if I want. But yeah, lambda transitions, that's all you need to say. Is it an NFA? Well, let's take a look. It's got our start. All the transitions look reasonable. I don't see anything wrong with it. Again, it doesn't have a final state, but that's okay. So yeah, it is. All right, let's take a look at this NFA, and we want to know, does it accept lambda? You bet, because you come in on a lambda. Does it accept A? Well, we come in on an A. No, it doesn't. Does it accept A and then a B? And of course, it's an NFA, so any path that you find is okay. So if we come in at Q0 and we do A, then B, yes, so it does. Does it accept AC? Well, if we look, if I come in on an A, I can only go C there, so no. What else have we got here? We have to look for ABC, ACA, ACB. So let's see. A, Well, ABC, we have to go here, and then there's no C, so we're not so good. But ACB we can do, right? So we can do ACB, but not ABC. Let's go, oops, let's see if we can fill these guys in. So we said ACB is okay, but not ABC. So ABC, oops, all right. I'm not very good at this. Let's do them in order. A, B, C. A, B, C was a no. ACA, no, if you look ACA, AC, and then what do we do? So ACA is a no. ACB, however, that was our yes, right? Because we did A, we went Q0, ACB, so that was a yes. ADB, that's looking promising, right? We do an A, a D, and a B, so that's a yes. And I'm running out of space here. What do we got? I wonder if I can copy these guys over. Hang on. Cool, check it out. Okay, does it accept ACBC? ACBC, AC, and is there a BC after that? No. ADCB, so we got ADCB, you bet. And then we have ADCBA, ADC. We could take a B down here or a BA, but either way we do that doesn't look promising. Okay, ACB, ABA. So ACB, ABA. Well, if I start to look at this, it looks like anything that doesn't end in a B other than lambda is a loser, right? It has to end in a B. So let's just look at what we got. We can get rid of anything that ends in an A. Look, the last few goes through D. So A, D, C, B. So we can do A, D, 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 C, B. Yep, that's okay. And what else? A, C, B, A, C, B, A, B, A, B. So A, C, B, A, B, A, B. Yep, that's all right. And the last one, ADC. So we got ADC, and then we got a whole bunch of BAs followed by a B. Sure, we'll take as many BAs as we want, and then the B. So yeah, that's another yes. Okay, so the last page was sort of the warm-up, and this page is take a look at this NFA and come up with a regular expression for it. So let's see what we've got. For starters, it accepts lambda, right? And it looks like it's going to be lambda plus some other mass, right? So let's just start to write something. So let's see, how can I move this over so we have space, but you still see the NFA? Yeah, it's not bad. All right, so we've got lambda plus. And you have to have, if you don't have a lambda, then you have to take this A. And after the A transition, you could have as many D's as you want, right? So that's going to be kind of A and then a D star. And then after the D star, what can you do? You can take just the B, and because we're running out of space here, I'm going to do plus a D star here, plus a D star, or you can take the C line and then as many BAs as you want, followed by a B. So I wonder if I can delete that part without deleting what I've got over here on the right. Probably not, but we'll see what happens. Yep, it went away. So we had lambda plus AD star B plus, and our other choice is to take the C, and then we said as many of those sort of, as many of these BA loops as we want, and then the final B. So to write that, we would say start with an AD star, and then take a C, and then take as many of those BAs as you want, right? 0 or more times through the BA, and end with a B. So I think that's my whole language, and we can write that. You can write it like that. That would get you full credit. You don't have to simplify it, but you can also write it a little bit more simplified. So we could write, I'm trying to have a space to write and also write it neatly. So we could write lambda plus, and then it was AD star, and I can just simplify it a little bit, and it's either times C, sorry, either times B, or it's times, start with a C, then as many, was it BA or AB? BAs as you want, and end with a B. So there you go. Okay, so we want an NFA that accepts this language. The easiest thing to do when you have a this plus this plus this is to just start with some free jumps. So I'm going to say, fortunately it's an NFA, not a DFA, right? I'm going to have that top one go to A star BC. So let's make that a lambda, and there's a 2, and I want this to be A star BC, so as many A's as you want, followed by a B to get to 3, followed by a C to get to 4, and we'll make 4 a final state. So there's one option. And then it says or AB star C. So here, maybe I'll try and colorize this a little bit. So for this AB star C part, we'll have another lambda jump, and otherwise you could have, there's state 5, you could have an A go to state 6, and state 6 has as many B's as you want. And then why don't we send it back to 4 on the C. Or I could have made another state 7 if I wanted and just have that be an accept state. And for this last part, A, B, C star, well, there's going to be a loop on the accept state at the end, right? So I'm going to have to, I mean, I could do it with a lambda transition too, but let's just do it the way it feels best, as it were. So I'm going to say it has to start. What am I up to? That's 7. It has to start with an A. And here's 8. Then it has to have a B. And finally it, well, here's my, this will be my accept state. So this is 9. And state 9 is a double circle. And it can have as many C's as it wants. Okay, so this is a tricky one. Proofs are always kind of tricky, right? So you're trying to prove that these two values, or these two regular expressions are equivalent. And, you know, I tried to lay this out as a problem with letters that kind of helped you to divide this into two separate, simpler problems. So if you look at this, we've got this T in the middle here that's there on the right, and they're just by themselves. And then when you look, the only pieces on the left-hand side with the CDB in them are that, and here's sort of the CDB stuff on the right. And similarly on the left, I've got this stuff that has the E's, the F's, and the G's, and on the right, I have these E's, the F's, the G's, and I guess maybe I incorporate this lambda. And I actually made it so that you could do that. So what I think is worth doing is trying, at least, it might not work, but in this case it does in fact work, to solve the individual things separately when you're just working on your scrap paper, and then to move to the bigger problem later. So this does not always work, but it's kind of a reasonable way to do this for this problem. So what I'm going to do is, instead of theoretically, you are supposed to put your answer in this first box, and you're supposed to use the second box for scratch space. But I'm going to try and I'll do things a little bit differently. Let's see what I can do. First, let me get rid of all those lines that I put on here. Magic. And what I'm going to do is I'm going to copy the equation somewhere where we can look at it a little bit more to do bits of it. So hang on 1 second. Now, for this exam, I actually gave you the copy of all of the properties of regular expressions that you're supposed to use for the paper exam. They were on the next sheet, on the next page of the exam. So here's what the next page of the exam looks like. I'm going to shrink this down for now, and maybe I'll just give you the pieces that it turns out that we need for, nah, that's a little bit cheating. I'm gonna move this out of the way anyway, and I'll kind of pull it back and forth as we need it. So what I'm gonna do is I'm gonna do the sort of approach that I've taught in class, which is write the two equations on the left and right side. Admittedly, I copied and pasted them, but they're neater that way. You'll probably like it better that way. And let's just see what we can do. So on the left over here, I wanted to do something with these e's and e star plus ef star g, and turn it into this lambda plus e star ef star g, or this thing, right? So if you kind of look and you say, what the heck what could I do with this? I mean, there's that extra lambda that I'm kind of thinking about. Maybe I should work from the right here, right? And maybe, because I love multiplying stuff out, right? And it looks like right here, I could do some kind of magical distributed thing, right, with these e's. So let's try that. And remember, I'm just kind of trying to mess around and see what I get, right? So what I think I'm going to do is I'm going to say, all right, I want to work on the stuff on the right up here, right? I'm going to start with this, and I'm going to work on this E stuff, right? And I mean, I see something I can multiply out using the distributive rule. I love the distributive rules. So what I'm going to do is I'm going to temporarily, because this is my scratch work, I'm just going to take all that stuff and I'm going to call that Q for now, so I don't have to copy over quite so much stuff. And then what I'll do is I'll see, what have I got? That means that if I multiply stuff out, I have the right-hand side equals lambda plus E times E star plus E times F star G plus, and then plus this whole Q thing, right? Which, let's see if this works. I think maybe I can shrink that little bit down a little bit. No, it won't shrink everything. There we go. All right, so I have this mess. And the reason for that is going to be one of the, can I grab him up here? Yeah, one of the distributive rules. Oops, it looks like it's going to be this one, right? Distributed 3.1. Okay. So So I'm going to say it is by distributed 3.1, and I have to say where what the R and the S, R and the S and the T are. So I want to say, what do we got? R is going to be, R is going to equal just an E, and S is going to equal an E star, and T is going to equal F star G. I think maybe I can shrink this in my notes. There we go. And let's shrink that in my notes. All right. And then I want to do something for this next part, right? So let's see. So now I have lambda plus EE star plus EFG plus Q is just the rest of the junk, right? Let's ignore that for a minute. And let me move this, properties regular expressions out so you can see what's going on over on the left. So now I have lambda plus E times E star on the right? Plus EF star G plus the rest of the stuff. And that EF star G looks good, right? That looks exactly like what I want. And so the question is, does lambda plus EE star, does that actually equal E star? Because if it does, then I'm good. I've got this piece, right, looking like this piece. And so what I do again is I pull out my my sheet here and I start looking at the rules for closure, right? They're the important ones. And what I want is I want to find something where lambda plus RR star equals R star, right? And because that's what I've got in here, right? I have a lambda plus RR star. You can see that, right? Right here, right? So that's, if I let E be R, then I have lambda plus EE star, right? So I'm going to grab this guy and make it bigger. And if you look at closure 5.2 here, you can see that R star is equal to all this junk equals lambda plus RR star. So this is exactly what we need. No coincidence. I tried to make the problem reasonably doable. So what we're going to do, again, we're still on our scrap paper here, is we're going to write this whole thing equals, let's see what do we got. We got E star plus EF star G, that's a G, plus all that Q junk, right? So let's make a little bit more space. And the reason for this, we said, was closure 5.2, right? Yep. And the reason, let's get our pen back, was, ooh, that's big, wrong pen. Closure 5.2, where R is just an E. So I think now I can grab this guy and shrink him. There we go. All right. So that was one part of what we did, right? Which was to mess with this sort of left side so that we could turn it into something that looks left side of this. The T we can leave alone. Let's just look at this piece now. The piece that I called Q before. And just because I kind of want to show you how to do this in both directions, I'm going to try and start on working on that part on the left-hand side of this. So on the left-hand side, we start with this T plus CDB star, right? So maybe maybe I should give this little piece a name too. Come here. Pencil, where are you? right? So let's call all of this bit, let's call that, I don't know, how about we call it, I can't write right now, it's not writing for me. Well, let's just call this X. So I'm going to write, there we go, X. Okay, so we're going to call that whole piece X. And so I'm working on the left now. So I've got the X part and the Q part. I want to change the, mess with the Q part now, right? So I'm going to say something like, this equals X plus T plus, now I have a CDB star, and I want to turn that into something that looks more like this. And so, you know, one thing is I'm looking at my rules. Can I make this big? You know, I'm kind of looking at my rules, and, you know, I feel like maybe I should just use the plus rule. Because if I just use plus 1.3, right, the R plus R equals R rule, because I know that I happen to know, so I remember that R star equals R star, right? So I figure if I can get two of these CDBs, if I can take this guy and turn it into two added together, then I can turn it into one plain old one and one multiplied. Let me show you what I'm thinking. So what I'm going to do is I'm going to say this is the X plus T plus a CDB quantity starred plus another CDB quantity starred. See if I can shrink. Oh, I don't want to shrink the whole thing. Come on, let me just shrink this little piece. Yeah, well, yeah, sorta. All right. And that was just by a simple application of one of the plus rules, right? Plus 1.3. So that was plus, fortunately this is my scrap paper, it doesn't have to look nice. So it was plus 1.3, right? And now I can use the, am I gonna grow? Yes. The rule that just says rule 5 here, 5.1. that says that R star equals R star times R star, so I can use that very nicely to get the sort of Q side of the proof to look nice. So I take my pencil and I say that actually equals the X part plus the T plus the CDB star that I had plus another CDB star, CDB star. Let's see if we can shrink these to a humane size. So I can say that's true by, which was the rule number again? Can I pop that up? Ooh, I don't like that whole thing's popping up, but anyway, it is 5.1, right? So it's by rule 5.1, and oops, I forgot in the previous one to say what the R's were. Here we've got the R, R is going to be just CDB, not CDB star, right? Because if we look at what 5.1 says, 5.1 says that R star equals R star times R star. So what's the R part of that? The R part of that is just the CDB, and then we star that whole thing, right? So this is my scratch work, but now I need to take my scratch work, oops, and move it over to the place where I write my proof in a fancy manner, right? So what I'm going to do, I'm going to see if I can do this in some way so that it shows up nicely for you guys and is not quite so ugly. So I'm going to start by copying the first line of, you know, the left-hand side to be the first line of my proof. So let's see what happens. Okay, folks, I have given up. I've been trying to find a way to handwrite this nicely and using this app, but it's not working. So what I have done is I have typed up my final proof here. The only thing I left out at the bottom of my proof is it should have a QED there. But you can kind of see how I put these pieces together, right? And so I started actually with the very left-hand side of the equation up here, right? And what I did was I said, all right, well, just to show you that I can do these in sort of any order, I'm going to do that little, I'm going to deal with this side first, right? And so I'm going to say, well, this raw piece actually equals this piece, right? So that's by closure 5.2 R equals E. And that equals this bigger piece, right? Because on this side, I'm moving upwards. If I started here, I have to go down this way and up that way. So there's the second line of my proof, which corresponds to this stuff. And then I need to do the stuff on the right. I need to get this piece to look like this piece, but that's this stuff on the left. So then I'm just copying what we have here to line 3. The only thing is here I actually put down what R equals. And then, sorry, the green stuff, line 4 gives us line 4. So that's the proof. Notice that each number is, each line is numbered. Line 1 is this thing equals something, and here's my reason for why it equals it. And line 2 is it equals this now, which is this, and so on. So there's my proof. And just so you can see it again, here's a copy of the properties of regular expressions by themselves.